Hello everyone, welcome to Sofa Solar Academic Training Class. This is John, the technical engineer from Sofa Solar. It is my honor to sit here share Sofa products with you. And the topic today is Sofa Star product 5 to 20 kilowatt 3-phase hybrid inverter. Let's start it. Let's do some introduction. So as Sofa traditional, we always offer a big LCD screen. Also for these products, it has 4-inch LCD with lots of different functions, and a dual MPPT tracker with 1.5 DC overload. And we also have a wide battery voltage range from 180 to 800 volts. And the max battery charge and discharge efficiency can reach 97.8. And it is very flexible to change between grid type mode, also the energy storage mode. We have 2 strings for battery input, and each input we have 25 amps per string, so totally is 50 amps. And we can also support the unbalanced load for both on-grid and off-grid mode. For the terminals, you can see the terminal 1 is for battery input, we have 2. And the second, terminal 2 is for DC switch. Terminal 3 is for PV input terminal. We have 2 MPPT, and each MPPT we have 2 strings. The terminal 4 and 5 is for AC parts. Terminal 4 is for load. Also, the terminal 5 is for grid. 6 is for USB and Wi-Fi. So the Wi-Fi dongle and the USB just share the same ports. The port 7 is for DRMS, it's for demo response mode. And for 8 is the COM port. If we want to communication with battery, also communication with the meters, we have to use this one. And the terminal 9 is for, and the terminal 10 is for link port. What is a link port? It's using for the parallel connections. We can support maximum 10 inverter connection for one system, can get working together as a 200 kilowatt hybrid system. And the terminal 11 for CT. One more important thing, if we're using meters, we don't using the CT. Okay, this is the parameters. I think most of our customers already read our data sheet, but I have to pick some very important things on the data sheet. First, number of the string per MPPT tracker. From 5 kilowatt to 8 kilowatt, we only offer one string per MPPT. And from 10 to 20, we offer 2 strings per MPPT. Also, the battery input, 5 to 8 kilowatts, we only have 1 battery input. And from 10 to 20, we have 2. And the charging or discharging current, each string limited 25 amps. Also, we have to making sure the maximum output of the current. Different capacity of the inverter have different output currents. We have some advantage of our inverter. We are using 5P connector for the AC terminals. and we support Bluetooth, RS485, Wi-Fi, and some other communication tools from inverter to your app or to your monitoring systems. From this picture, we can see what is the system component with: panels, batteries, critical load, normal load, and we also need a smart meter to help our inverter know how many power input or output to the grid. This is the circuit. The circuit that we also have in the user menu. We can follow the circuit to set up our systems, and we already marked down the cable size and some important details. So please check it when you make the installations. Startup procedure. It is very important because we need you set up some important details when you set up the inverter. First, making sure there's no electrical energy in the inverters. Second step, we have turn on the DC switch. Then we have turn on the battery. Please making sure turn on the oscillator between battery and the inverter if you have it. And then turn on the AC circuit breaker between the grid port. Step 5, just turn on the circuit breaker between inverter and the load. And then the inverter will start working. When the screen is on, we have to make some selection. First, the language. The default language is English, and we will have more options for you, so you can selection through the buttons to choosing your own language. Step 2, set the time. Step 3, safety parameter import. We need using the USB or so far Bluetooth tool to help us set up the parameters. Step 4, input the channels. And step 5, we have to choosing the battery parameters. If you using the leasing battery already compatible with so far, just selection between different battery type. If you using lead acid battery, maybe you need input some more details like maximum charging, minimum discharge voltage, charge current, and some other details. After you set up the battery, or the setup is complete. And you can see this picture. This is for input channel configuration. If you have 2 battery pack, you can selection battery input 1 and the battery input 2. If you have only one, just set up the battery input 1 and the battery input channel 2 set to not use. It's the same for the PV. And now it's the working mode. Mostly we're using the self-using mode. What is the self-using mode? Just we can consider the power from grid side, PV side, also the battery to make selection battery charging or discharging. For example, if PV generation equal to the load consumption, inverter would charge or discharge the battery. If the PV generation is larger than the load consumption, the power will go to the battery first. If the battery is full, the extra power will export to grid. If the PV generation less than load consumption, the PV will work together with the battery to support your load. And if your PV and the battery add together even smaller than your load, so inverter will take in power from grid. So three parts working together to support your load. So we can see the power supply, PV is first, then battery, last option is grid. And for consumption, load is number one, second is battery, and the grid also the last options. Just making sure not taking too much power or not export too much power to grid. Also, we can set up the anti-reflex. Anti-reflex is the option in our inverter. It is the main power limited functions. We can limit the charging power to 0 or other value we set up. Second is the time of use mode. For time of using mode, we just selection, because sometimes the solar power is not enough for your load, so battery always empty, and sometimes the price of electricity is cheaper at the evening, so we can set up a special time charge the battery, and then in other time period it will work as the auto mode, just our self-use mode. Timing mode. For timing mode, mostly we just using for test the battery charging or discharging functions. So we can selection a time and the charging power, also the discharging time and discharging power. At those time period, battery will charge or discharge. Other time period, it will working in standby. Battery will not charge or discharge. Passive mode. So far, if you need it, so far we'll offer you the RS485 communication portal and the passive portal. You can using our portal to control your inverter. Maybe using app or your monitoring systems to program a special mode. Give a commander to the inverter and selection the time to charging or discharge. Just give commander to inverter, you need to charge now, okay, it will charge. It will discharge now, it will discharge. For EPS mode, EPS mode just working like an off-grid mode. Just if we lost the AC connection, it will work as an off-grid inverters. If PV generation is bigger than load, the extra power will charge battery also. And if PV generation equal to load, the battery will in standby and the inverter won't charge or discharge the battery. If PV generation is smaller than the load, the inverter will discharge the battery. Solar and the battery will working together to support your load. And if the PV generation is normal but the load is 0, the extra power will all storage to the battery. Application mode. Okay. Through this picture, we can see it's a typical energy storage systems. This is very typical ones. So you can see PV, inverter, battery, load, meter, everything is here. This is standard one, but sometimes we can you will using the system in different conditions. First, system without the PV connection. So our hybrid inverter will working as a battery charge and discharge controller. So we can take in power from grid to charging battery. Also, we can take in power from battery to support your load. Second, without battery. If our inverter without battery, it will working like on-grid inverters. This is just like a grid tie, standard grid tie inverters, standard grid tie systems. Backup without grid, as I say, working like an off-grid. When grid is down, or you don't not using grid in peak hour, you can shut down your grid using the panel and the battery only. System with multiple inverter. As I mentioned at the beginning, so far hybrid three-phase inverter support maximum 10 inverters, and the capacity, for example, one inverter is 20 kilowatt, so the maximum capacity for whole system can reach 200 kilowatts. AC roof system. We need help with 2 meters. This meter testing how many power from grid tie inverters, and this meter show us how many power import or export from grid. So the hybrid inverter can know where the power goes from, and we can control the battery charge or discharging it. This is very good for some customer if they already have grid tie inverter and increasing their solar capacity. And it can working as an AC couple inverter, just working without the panels, but working with another exist grid tie systems. For this time, for this mode, it is very good for some customers who already have a solar system and do not want to remove their panel or add some more panels. And we can have the backup. The backup unbalanced output. So when the grid path is disconnected, and we can support the unbalanced load during the off-grid. For example, phase A needs 1 kilowatt, phase 2 needs 3 kilowatt, and phase 3 needs 5 kilowatt. So the total power from PV and the battery, also the inverter system, will support totally 9 kilowatts, giving the right power to the right phase. Also, on-grid unbalanced load. For some country, no power can export to grid, so we need to do the power limited. But as you know, the load each phase is unbalanced. No worry about it. For the three-phase hybrid inverter so far, we also support the on-grid unbalanced output. Okay, this is the picture for battery connections. You can see here we have 2 packs of the batteries, battery 1 and battery 2. But making sure the maximum current each input is 25 amps. So 2 terminals, totally 50 amps. And we recommended you to using 2 independent battery string to connect to the inverters. Monitoring. For our inverter, the monitoring always support for our monitoring system, so user can go through their PC or mobile phone to check the status of their inverters. The data will go through inverter. The data will go through the inverter data logger to the router, updated through the internet, and you can see it through your app or your computers. And this is the picture about the apps. So the flow chart is here, the grid information, the battery information. Also, we already help you set up some Alexas so you can read it. You can know where the power coming from, and you can know where the power goes, how many power you generated, how many power export to grid, how many power storage to the battery. This is the picture for PC side. Also, you can see here 4.95 from the PV, and the consumption is 6.5. Battery this moment is empty, so we taking some power from grid. Also, you can using the self-using info, just making sure the power, where the power coming from, power from battery, power from PV, or the power from the grid. The advantage at the function. First, the backup automatic switch over time is less than 10 milliseconds. Second, remote upgrade function. Also, we can do the change settings through the apps or do it remotely. Third, we have different monitoring solutions: Wi-Fi, GPS, RS-485, Bluetooth, and so on. 4. Anti-reflex function. This is just like a power limited functions. 5. Compatible with multiple brand lithium battery, also the lead acid batteries. Every cool scan, it will help the solar increase the power generation. Without the remote firmware upgrade, we can do the setting change, also the firmware upgrade locally through the USB. And we have multi-application mode, suitable for different applications. The HYD 3-phase energy storage inverter have a capacity from 5 to 200 kilowatt for one dependent energy storage system, so it can fly different switches and need uninterrupted independent power supply to cut their electricity bills. For example, supermarket, hotel, factory, school, farm, and different situation and different conditions. This is the end of the class today. Thank you for joining us. If you have any question, please let us know. You can contact us through the phone call or give us an email to service@sofasolar.com. Thank you.